Okay, let's look at the chain rule in combination with other rules. So right here, what are we looking at? We're looking at a product of two functions. Now let me go ahead. I always start by rewriting that square root as the 1/2 power. So let's take the derivative here. It is the product rule. So first times the derivative of the second. So x squared times the derivative of the second requires the chain rule. Exponent, subtract 1 from the exponent, times the derivative of the inside, negative 2x, plus the derivative of the first, 2x, times the second. Okay, so how would they clean this one up? All right, so when we end up with stuff like this, the biggest thing we need to look for is, first of all, can we simplify some coefficients? So 1/2 times 2, that goes away. So we've got an x squared times a negative x. So let's go ahead and write that as negative x cubed. I'm actually going to leave this for the moment because when I look at my second term over here, I have something that's not exactly the same, but it's very closely related. So let's see what we have in common between these two terms. Both of them have an x, so we're going to factor out an x, and both of them have this 1 minus x squared, okay? They're not raised to the same power, but here's how we want to do it here. We want to factor out the smallest power, so we're going to factor out the negative 1/2 power. So let's analyze here for a second what we've got left. If we take an x out of negative x cubed, we're left with negative x squared. We factored out this expression right here, so we're done. Plus, we took out the x, but we didn't do anything with the 2. Here, when you factor out a GCF, remember that one way to figure out what you have left is to divide. So if we divide this expression, 1 minus x squared to the positive 1/2, by 1 minus x squared to the negative 1/2, what do we do with exponents when they have the same base and we are dividing? We subtract them, right? So 1/2 minus a negative 1/2 is 1. So really what we've got here is 1 minus x squared. Now, remember, you can always check your factoring by multiplying it back out. So if you don't really believe me on this, let's multiply it back out real quick. X times negative x squared is negative x cubed. And of course, then we tack on this expression right here. Plus, x times 2 is 2x. 1 minus x squared to the negative 1/2 times 1 minus x squared to the first. Add those exponents. What do we get? Positive 1/2. So by doing that, what this allows us to do is really, we're going to combine some like terms in here big time. I'll deal with the negative exponent last, okay, because I want to get everything up here simplified first. So when we distribute the 2, we get 2 minus 2x squared. So we've got negative x squared minus 2x squared, so that's negative 3x squared plus 2. And so then, final answer, we've got the x and the negative 3x squared plus 2 in the numerator over, we've got this expression, getting rid of the negative exponent, move it to the denominator, put it back in square root form. Okay, so pretty neat. And not too complicated, but this whole factoring out the negative exponent may be kind of new to you. So if you may need to go back and rewatch that one just to see exactly what I did on all those steps. All right, here we go. Here's one. Looking at it, what rule pops in your mind? The quotient rule. But do we really have to use the quotient rule on this? Because if we don't have to use the quotient rule, I really don't like using the quotient rule because you have too many opportunities to kind of mess up your signs because of that minus. And it's just, especially with the square root, I don't know. How about we just rewrite this as x times x squared plus 4 to the negative 1/3. Okay, bring that cube root to the numerator by making it a negative exponent, and it's the 1/3 power. So then really we just have another product rule, okay? You could have done the quotient rule. If you want to do the quotient rule, pause the video and knock yourself out. I just really don't want to be quite honest. So let's do the product rule. Okay, first, times the derivative of the second. Bring down the exponent, keep the inside the same, subtract 1 from the exponent. If you're not getting good at these fractions yet, you better be getting good at them because I promise you they're not going to go away. Times the derivative of the inside, times 2x. Plus the derivative of the first, well, that's nice, it's just 1. Times the second. Okay, so what are we looking at? We're looking at what we just did a second ago, all right? So 1/3 and 2, unfortunately this time they don't simplify. So let's go ahead and just look at what we can factor out. We've got x squared plus 4. We take out the smallest one. So we're going to take out that -4/3. So what are we left with? We're left with let's see here, 2 times -1/3 is -2/3, and x times x is x squared, so -2/3 x squared. I took that part out, so that's factored out. Plus, I don't need to worry about that 1, -1/3 minus a -4/3, so it's like adding 4/3, so -1/3 plus 4/3 is 3/3. Guess what's going to happen almost every time? That's just going to end up being to the first power. Most of the time. Don't automatically do it, but it should always at least give you a whole number, if not just 1. Okay, so we're really close to being done, actually. And if we'd done the quotient rule, we wouldn't be that close. So -2/3 x squared plus 1x squared. -2/3 plus 1 is a positive 1/3 x squared plus a 4 over, I'm getting rid of this negative exponent right here. And let's go ahead and put it back in radical form. X squared plus 4, and that's all raised to the 4th. So, not too bad, right? Quotient rule, you would have gotten there, but I promise you it would have been more work. So I think it's really easier just to do it this way. All right. Here we go. Here's another one. Again, another example. You could use the quotient rule, or I would rather typically, not always, but typically, if you can rewrite this algebraically, because what we're looking at right now is we're looking at a chain rule combined with a quotient rule. I don't really like the sound of that. So if I can rewrite this algebraically, meaning apply that power of 2 to the numerator and the denominator, which I can do. That's a property of exponents. And then I really do not want to do the quotient rule. So use another property of exponents and just move it. Move it to the top using a -2 power. So we're just going to have to do some factoring in the end. Okay, so first, 3x minus 2 squared times the derivative of the second. This does require the chain rule. Bring down the exponent, keep the inside the same, subtract 1 from the exponent, multiply by the derivative of the inside. Plus the derivative of the first, bring down the exponent, keep the inside the same, subtract 1 from the exponent, multiply by the derivative of the inside, times the second. Okay, the majority, what happens when people are doing this is they tend to leave off the details. They're not used to having expressions this long, and after they apply the chain rule right here, they'll forget to multiply by the second term. Okay, so please, please, please do not rush through these problems. Take your time and make sure that you're getting each and every rule that you're supposed to be applying. So let's see what we've got here. We've got -2 times 2x, so that's -4x. I'm just going to kind of combine like terms as much as I can first, and then we'll look at what do we need to factor out. 2 times 3 is 6, and 3x minus 1, and x squared plus 3 to the -2. All right, so what do we have in common here? Well, obviously we can take out a 2. Whether you want to take out a positive or a negative, really that's kind of up to you. And honestly, if you're doing a problem like this on the multiple choice portion of the exam, once you apply the rule and do the simplifying first, so what I'm talking about is when you get to this line, just glance at your answer choices. See how far they really take things, because when you look at your answer choices, either they will have a 2 factored out or they'll have a -2. So that kind of tells you where to go. All right, well, do I need to take out a positive 2 or a negative 2? Look at the answer choices. It should be pretty clear which one they did. I'm just going to stick with a positive. Typically, if it's a negative leading coefficient, I do a negative, but, whoops, sorry, I'm getting ahead of myself. I didn't get my whole GCF. Let's try again. I'm talking too much and not focusing on the problem. Okay, so what else do they have in common? They have 3x minus 1, just one of those. Okay, one of them has 2, one of them has 1, so you can only take the minimum. And then here, we've got x squared plus 3, and remember, we want to take out the smaller one, so we want to take out that negative 3 exponent. Now, I'm going to put a bracket just because I have so many parentheses here, just to kind of set it apart. So if I took out 2, I've got a negative 2x left. I took out one of those, so I've got 3x minus 1, and I took out that whole expression right there. Plus, I took a 2 out of the 6, so that leaves me with 3. I took this part out, and when I subtract these exponents, negative 2 minus a negative 3, guess what? Positive 1. I told y'all that's usually what happens. Okay, so let's keep simplifying a little bit. Leave this first part in factored form. There's no point in trying to multiply all this stuff out right here.